Good afternoon, everyone. I'm Jyoti Bali here, presenting the problem developing project management skills to enable engineering faculty to handle multidisciplinary projects. Along with me, Professor Arun Kumar Giriyapur, HOD, Department of Automation and Robotics. Presentation contents are as follows. I'll be starting with the motivation, need and problem definition, proposed methodology, results of implementation, and the conclusion. So as the title says, we are trying to solve a problem which is trying to develop project management skills among faculty, mainly to handle multidisciplinary projects. Project-based learning has become the mainstay of autonomous curriculum, unlike in the affiliated institutions where there's a very little scope for project-based learning for students. Here, under our autonomous scheme, we have students' projects ranging from the scale of hobby projects up to capstone projects, and the activity is so important as it enables students to gather professional skills like teamwork ability, project management, problem-solving ability, use of research tools, so on. As the activity is a very important factor, and we need to gear up faculty guides in that direction. So involvement and contribution of faculty guides proves to be very critical. So we need to make our faculty or ourselves develop those critical skills required to manage, supervise, and guide students. In that direction, we try to check for the challenges what we faced at our department, that is automation and robotics. As you can understand, here we mainly concentrate on multidisciplinary project management, where the components of project belong to domains like having electronic circuits for signal acquisition, signal conditioning, and actuation. And we need to program some controllers like microcontrollers, PLC, FPGA-based systems. And we need to even have mechanical systems where you employ some modeling softwares and you try to model them, later try to implement or fabricate the automated mechanisms. And similarly, the faculty also who are in the department, they belong to different disciplines like electronics, electrical, mechanical, and computer science. So naturally, a staff belonging to a specific domain cannot handle this multidisciplinary project alone. So in that direction, we need to evolve a strategy. So we did the need analysis. Here, as the projects are of multidisciplinary type, we need to follow engineering design process and the concurrent approach of mechatronic system design methodologies. And role of, as I told, role of individual guide proves to be very difficult here. And we have the constraint that we need to address these NBA graduate attributes for accreditation, mainly in the areas of problem analysis, design and development of solutions, investigation of complex problems, modern tool usage, environmental and societal considerations, ethics, teamwork, communication and lifelong learning, as well our program-specific objectives also. These are the generic whatever I listed above, and program-specific objects are in line with automation and robotics program. So we sat together at the Department of Robotics. The faculty members did the brainstorming, and we tried to do the root cause analysis for the poor quality of project prototypes which are being done by students. So one of the very reason was, which we found out, was the lack of competency among faculty to provide effective guidance to the students' projects. So the contribution, because it was multidisciplinary project and the staff guides belonging to specific domains were not able to completely do the contribution and involve in the students' projects. So we need the need was to analyze a strategy or evolve a strategy by which we can improve the project management skills of trainers. So we started planning the processes for finding out the solution. So we thought of implementing it. We arrived at the solution, which consisted of two phases. One is a training phase, and the other is project phase. So a conscious, you can say, this methodology, what we adopted as a solution, is a conscious approach to develop the technical and the project management skills to handle multidisciplinary projects. So under training phase, we try to train staff on the design processes, which I referred it as engineering design process and the mechatronic system design approach, and training on general hardware and software available as a resources in the department. And as you can understand, training phase is a regular activity which should iterate in cycles, and it's not that it is a one-time activity. So we are still in the process of training phase as well undergoing project phase in a simultaneous fashion. So for training phase, we have a training calendar by which we are trying to train all the staff in a phased manner by industry experts. So for that, I have given the plan in the next few slides. In the project phase, we try to make faculty teams, and we make them undergo similar activity what the students undergo through the project work, by which we try to make them solve a problem through the design approaches what they've studied in the training phase, and we make them build the solution and test the project prototype, so that they'll undergo the similar experience what students undergo, by which they try to gather some skills which are really needed to involve with student projects and develop a solution along with them. So we had the planning of the time for the activity. It is mainly in the vacation time, in our summer vacation after our even semesters. We have a good number of holidays, or you can say leisure time, in which we can engage staff in this activity. So training phase, I'm showing it in the form of a flow chart, where we say the various steps involved, sequential steps what we have shown, where we try to generally divide the domains for research problems. Usually students gather research problems. Similar way, we want the faculty to do this, and we analyze the problem to arrive at the block diagram of the proposed solution. And once we have a black box approach from this block, we can identify the subsystems present in the solution. So immediately after that, we try to do the formation of faculty teams, where a group of 2 to 3 members belonging to a specific domain, like electronics domain, mechanical domain, they have their own teams, and they try to work on the subsystem design. So next thing is, after we do this simultaneous work, that is the training phase is going on, where we try to train staff in the available resources. So mainly our stress is on training on the drive systems, signal conditioning circuits, controller programming, and mechanical design softwares. And as well, the generic engineering design process and mechatronic system design approach will also be dealt as a training part. So from these steps, we try to evolve faculty teams where we can have collaborated team members, where one person belongs to software, the other person belongs to electronics domain, the third person belongs to the mechanical domain. So a team gets evolved from this training phase, where a staff team will be comprising of multidisciplinary skills who will be well equipped for guiding a multidisciplinary projects what students undertake. So framework we have developed for the training phase based on the resources available in our department, based under these headings: need analysis and use of modeling software, sensor selection, signal conditioning circuits and the design, choosing of controller programming, mechanical design, use of drive circuits, actuators and various modules. For the resources what I have shown here, which are available in the department, we try to even identify the industry experts for training. Okay, we have our regular vendors whom we take various products for our department. Beckhoff Private India Limited, Bosch, Rexroth, Electronic Solutions from Bangalore, so on. We are still in the process of finding out industry experts who can support in our training phase for faculty. So scheduling of this training phase, we have prepared a training calendar as per the convenience of faculty members during the summer vacation. As well, some few training we have planned in the regular semesters also. So under project phase, we have again the algorithm developed. We have stage-wise sequential steps. What you can show. So in the once the faculty teams, evolved faculty teams are there, which are going to address the multidisciplinary skills. Yeah. So we are doing the selection of problem through literature survey, brainstorming, tools of ED process, studying the feasible solutions for concept generation, brainstorming, analysis. So as you can see, these are some standard steps which any project solution should involve. So you can see that we could identify subsystems, and the faculty teams will be able to now work on their subsystem discipline wise, and they can approach this concurrent approach of design for the development of solution. So concurrent approach involves ensuring the compatibility between subsystems in every phase. So we are involving staff to develop not only the design solution, even the fabrication, building the prototype. So finally, fine-tuning of settings of the prototype. We can do the testing and validation, and later we can do the project solution implementation in the form of report, paper, and poster. So this can be one approach by which uh, trainers gather a lot of inputs regarding the way how the project is carried out by students, and what are those challenges and the problems what they experience. So this is a flow chart regarding the project phase. Okay. So our focus was the faculty collaboration for effective project management. So we ensure that the faculty teams, involved teams, are going to manage the projects in a better way with effective guidance to the students. So about the activity, what we planned, we collected the feedback from staff and students. You can note that the green area shows the consent with which they have undergone, and the way the students welcome this idea of having the experiential learning what staff will share with them through this methodology, what we as a strategy we followed for project implementation. Okay, we are still in the process of refining these sequential steps what we have decided for training as well as project phase, and we are trying to implement. As a result, I can present it's not fully, it's only the partial results, as it was only 1 year completed after we thought of implementing the strategy. And you can we could do it only for one batch. There is a passed out batch of students who were in 2015 passed out batch students. where we could not implement much improvement in the project prototypes, but in their documentation skills, the way we evaluated their paper in the poster, we had a lot of improvements. So only I've shown project prototypes as the thing which we still need to emphasize on, but on the project reports, paper presentation, and poster presentation, we could do a lot of innovation and we could make them learn better. So some of the projects what our students developed in the last year, were prosthetic hand, which got accolades in the national level competition, Jedi competition, and as well in the national level competition of 2015. Similarly, many of the solutions were developed, but we can see that they were not so much of fine-tuned with respect to the fabrication aspect, the way that it was implemented, the way the accuracy in the performance was concerned. So this is one food grain packing machine, whatever these students did, and one was railway track crack detection mechanism, what the students one batch implemented. So similarly, we have a bottle filling and capping mechanism, what our students implemented. But as I understand, the prototypes would have been better, where in this the faculty contribution in the design and the implementation was not so much rigorously done, because of which the prototypes still had some limitations in the performance, in the efficiency what they presented. But with respect to the documentation skills, like presenting their solution in the form of their project report or in terms of the poster, this is one sample poster what our students have done, where they could convert the entire work as a one-page report, and they could present their work in the beautiful manner. It was one team called Team Pinnacle, and the other team which did this food grain packing machine. You can see the poster. And similarly, one more poster I've shown here, which is for bottle filling and capping mechanism. We could evaluate the results through an external examiner. We are calling one external examiner who is there in the panel from last 2 years. So he could compare the previous year's prototypes, the project reports, poster and paper with the earlier batches, and we could gather the feedback this way. He appreciated the design process followed, mainly the engineering DD process and the mechatronic system design methodology what we implemented, and the quality of project reports he appreciated a lot, where we okay, just to express what does this essay, it is strongly agree. We had given a questionnaire by which he evaluated the performance of this batch. It's the average performance of all the batches together. This essay stands for strongly agree, which talks about the positive effect of the activity, whereas disagree and strongly agree, these are some negative points. You can see that majority of things he could say that's an improved thing compared to the previous. It was relative performance, but we hope to add some more inputs by which we try to gather data, by which we can understand the real scenario through the feedback. So that we are planning to do for this semester for the capstone project of our final year students. Similarly, we collected the feedback from staff and students on project implementation. So in many of the cases, you can see that faculty are they have given very positive feedback regarding their involvement, how it could improve, how it has improved the project prototype or the documentation part. Guidance from faculty, are they happy with this time they could involve in a better way compared to the previous after implementation of this strategy what we planned by means of training phase and the project phase. Relevance of design process, we have evaluated. Improvement in the prototype also we have evaluated through the feedback. quality of reports. There's a drastic improvement. Even students say they're agreeing with the things whatever they have tried to accomplish through the project work. So as a conclusion, I can say quality of student project can be always improved through faculty, direct involvement of faculty, supervision, and timely advice. The proposed activity addresses important requirements of MBA new graduate attributes, by which we are going to satisfy majority of the outcomes. To add the component of research skills is also our scope in the next activity, while we refine these processes for improvement, for developing the staff competency, mainly with regard to management of projects. So I referred some papers. So some are mine, some are, you can say, well reputed papers in the field of engineering education I could refer, and I could present this solution. So I just want to add one thing. So this problem, whatever we have identified and whatever solution we are implementing, it's a regular thing which should continue. It may take some few years till we stabilize and say that we have developed very good competency in project management, because there will be, this system involves staff coming in, staff going out. So always this process has to continue. We have prepared a calendar by which we try to, we have planned a schedule by which we try to monitor the things, whatever we are trying to do. So this is for the day. Thank you so much.
Thank you, madam. We'll give the attendees 1 or 2 minutes in case they have questions.
Okay, sir.